So here we're going to practice writing net ionic equations. Just 3 steps. If this is kind of a long way. Once you know this. Number 1, start with a balanced equation. So I have an example equation we're going to do, but it's not balanced yet, and I didn't fill in the states of matter on the product side yet. So we're going to start with a balanced equation, then we're going to write a complete ionic equation, then we remove spectator ions. So that's it. So we've got nickel nitrate. You're going to be given some sort of list of solubility rules, or you can look up a list of solubility rules. Nitrates are almost always soluble, so you're going to see nitrates in many problems in any textbook. So we've got nickel nitrate, and we've got potassium carbonate. Potassium is an alkali metal. Potassium is very soluble, so anything you put potassium with, it's going to be soluble. So you're going to see potassium a lot, along with sodium, but the alkali metals are soluble. And we've got carbonate. So we look on the products. These two are aqueous. Right? We have 2 species that are dissolved in water, and we have 2 products. What we did is we looked at these compounds, and okay, we've got a cation and an anion, a cation and an anion. So what would happen if this cation went with this anion, and vice versa? And that's the pairing that we have on the product side. Just so you know, the nickel here is +3, and the nickel is +3 on the product side as well, and carbonate's -2 as a reminder. So we look at these and we got to say, okay, did any reaction happen? If everything just stays dissolved, if it starts off aqueous and it ends up aqueous, there's actually no reaction that takes place. It's simple. But we have potassium nitrate here as our first one. Potassium is always soluble. Nitrate's always soluble. So we're going to give that an aqueous. Then we've got nickel carbonate. Well, you're going to find, you don't find a rule for nickel, but you do find a rule for carbonates, that carbonates are generally insoluble. So there's going to be our solid. Okay, so this is a precipitation reaction. We're precipitating nickel carbonate in this reaction. So we are getting to step 1. So now we've got to balance it. We've got 2 nickel ions on the product side. So we'll put a 2 here, and we have 3 carbonates on the product side, so we'll put a 3 here. And we've got now 6. Okay, so now it's a balanced equation. We're done with step 1. Now we're going to write a complete ionic equation. To do that, we take any ionic compound that's aqueous and we split it into its ions. Make sure you count appropriately. Like you've got coefficients here as well as subscripts, so make sure you're multiplying. Solids, if it's a solid ionic compound, you leave it together. So this is going to get pretty long. There's 6 nitrates. So I have all the states of matter. Those are all the ions that are present as far as this reaction is concerned, this equation. So we did that. We wrote a complete ionic equation. If you're asked for that, this is what it would look like. You have states, put the states of matter on next to everything. Next thing is to remove the spectator ions and reduce coefficients if possible. So spectator ions are ions that appear on both sides of the equation in exactly the same form. And in this case, it's going to be nitrate. We see 6 nitrates on the reactant and product side, so those are spectator ions. And we have 6 potassium ions on the reactant and product sides, so those are spectator ions. So I'm just going to write the net ionic equation down here. So there's a net ionic equation. Coefficients are 2, 3, and 1. So I cannot reduce them. If it was 2, 2, 2, take it down to 1, 1, 1. That's a net ionic equation.